Okay, in this video we're going to go over implicit differentiation. And now one of the things, I've been playing around with lots of different notation, but I really like the dy dx notation. And that's really important for implicit differentiation. And so I really want to sort of we've been playing a little bit fast and loose. We've been going, oh, so y equals x squared. So y prime is equal to 2x. Or we say f of x is equal to 3x to the fifth. So f prime of x is equal to 15x to the fourth. Okay, fine. But I really want to change things around. Okay? And I want to write, this is okay. But now I want to change things around conceptually. Okay, so now what we're going to do is, if we say y equals 5x cubed plus sine x, I'm now going to say that dy is equal to 15x squared dx plus cosine x dx. Every single time I take the derivative, I'm going to use my derivative rules, and then I'm going to put a d whatever that was out in front. I'm going to go even a little bit more crazy on this. I'm going to say 5a to the fifth plus tangent b plus e to the c equals d squared minus 4d. Now, what implicit differentiation is, I'm starting off a little bit too theoretical, but what implicit differentiation is telling us is that the way that I'm going to do this is I'm going to do 25a to the fourth dA plus secant squared b dB plus e to the c dc equals 2d dd minus 4 dd. So that's kind of like that's about the most general that it gets in terms of taking the derivative. Is you just sort of, whenever you take the derivative of something, you just throw a d whatever that variable is out at the end of it. Okay? So why is this important? Okay, so implicit differentiation, one of the places it can be used is implicit functions. So here I've got a really nice simple function. That's the unit circle. So I've got my unit circle, and I want to know what's the slope of this line, say right at, what's the slope of that line at pi over 4? Well, I'm pretty sure it's going to be -1. But how do I find the derivative of this? How do I find, okay, maybe I can change it into y equals square root of 1 minus x squared and do it just in the first quadrant, but I want to be able to do it all the way around. Okay, so here's what we're going to do. We're going to write x squared plus y squared equals 1. And we're going to say, what's the derivative of x squared? It's going to be 2x dx. What's the derivative of y squared? It's going to be 2y dy. What's the derivative of 1? It's just a constant, so it's 0. So now I'm going to get 2y dy is equal to minus 2x dx. And I'm going to do a little bit of algebra, and I'm going to get dy dx is equal to negative x over y. And you guys can figure out the algebra on your own. So then, if I plug in the point, in the point square root of 2, comma, square root of 2 over 2, which is the coordinates of that point, get negative 2 root 2 over 2 root 2 equals negative 1. So the slope of that circle at this point here is negative 1. What's the slope at that? I should come up with 0. Well, what's the x-coordinate there? The x-coordinate is 0. What's the y-coordinate? The y-coordinate is 1. So if I go negative 0 over 1, I get 0. So you can use implicit differentiation to find the derivatives of implicit functions. And so then there's also, if I just sort of, I don't know if I really want to go and do much more of that. So we're going to hit that again, looking at some inverse functions, so I don't feel so bad just spending just a couple of seconds on that.